Hello, my name is Zachary Chenoweth, and this is my presentation of Lab 4, Task 3, Path Planning with No Noise. Now for this task, we have to have our robot start from a known location facing a known direction, and we have to get it to go into the requested goal cell using the shortest path. Now we're going to use path planning algorithm. The path planning algorithm I chose is the wavefront algorithm in order to complete this task. So let's go ahead and look at the code. We have all of our initialization of the sensors, et cetera. Here we have the goal cell. So this is the cell that we want our robot to end at. We have the starting pose, which is the cell that the robot starts in. And then we have the initial direction, which in this case is north. Here we have a data structure. This is going to hold the map of the world. So it has all the internal and external walls mapped here. This print maze function is basically going to print this grid, and it's going to print all the numbers used in the wavefront algorithm, which I will explain here in a minute. This is just going to print the maze. Here we have the actual wavefront function. Now, the way the wavefront algorithm works is it's going to place a number 2, on the cell where it begins. So here we can see. So the starting cell is here and the goal cell is here. So it's going to go ahead and put a 2 at the goal cell. And then it's going to loop through and it's going to move along and it's going to place the next highest number, so 3, in all available cells it can move to. So because this goal cell, the only way it can move is this way, it's going to place a 3 here. And then it's going to place a 4 here. But now since 4 can go, since the next cell can go either this way or this way, it's going to place a 5 here and here, as you can see there. And then we're going to go again. Oops. Apologize. So it's going to place 5 here and here. And then the next one is going to place a 6 here and here because it's moving down. And it's just going to keep moving through until it gets a number into the starting cell. So once it gets the number here, then it's going to go ahead and move into this planned path function. This is where it's going to actually decide which path it's going to take. So it does that by basically going through and seeing from the starting cell, it's going to see that number. So in the example I just showed, this number was 8. So it's going to say, okay, our current cell value, the value is 8. So we're going to look at the cells around it to see which one has the next number, which is 7, which in this case would be this cell here. And then it's going to do it again. It's going to check its cells around it, see which one is 6, then 5, then 4, then 3, then 2, and so on until it gets to the goal cell. So it's going to go ahead and do that here, and that's all this does. And basically, once it's done mapping out the path, then it's going to go ahead and we're going to go ahead and start traversing that path. So another thing you can see here is the way that I have my actual movements set up. The left turns and right turns don't, they only turn 90 degrees. And that's all those functions do. So it doesn't turn all the way around. It only turns 90 degrees and it doesn't move forward. So let's say, for example, if I'm facing south here and the goal cell is here, for this first motion, I need to actually make 2 left turns before I can move forward. So that's why all these if statements are here, is to show the multiple movements it takes to make one movement. And I'll show you this in more detail when I show the printed plan path. So that's all this does here. The forward function is what actually, when this is called, it's going to make our robot move forward. It basically gets a distance traveled, and as long as that distance traveled is less than 10, it's going to set the robot's velocity to these. Once it's done, it's going to stop the robot. Turn left, this is the same as it's basically been in my last several videos. Basically, it's going to look at the IMU's value, and as long as it's within these set ranges, it's going to go into these if statements, and then it's going to turn 90 degrees to the next cardinal direction. And then once it's done, it'll stop moving. Same with right turn. It's exactly the same as the left. The only difference is that it's making right turns instead of left. Here's the function for actually traveling the path, and basically it's going to take the planned path that we had earlier, and it's going to loop through, and it's going to complete all the motions that we designate, which I will show here in a second. So if I run this program, we can see that. And then I'm just going to call the functions, and then once it's finished traveling the path, it's going to print goals stating that it's in the goal cell. So we can see here, it's going to print out all these to show the wave, and the wave going through and placing the numbers in the cells. And then here is the planned path. So as you can see, because we're in the cell facing forward, it's going to take 3 forward motions, a left turn and a forward motion, and then 2 more forward motions before it can get to the goal cell. And that's the planned path. And then this number that you see next to it is the cell that it's going to. So for example, we're starting in cell 16. If we do 1 forward motion, we're going to end up in cell 12. Again, if we're in cell 12 and we do 1 forward motion, then we're in cell 8. Another one, and we're in cell 4. And then if we turn left and go forward, then we're in cell 3, then 2, and then cell 1. So these are the cell that this is the cell value that we're going to. And then now we're going to go ahead and see the robot travel that the specified path. And notice that it did take the shorter path. So that's fine. And then once it's done, it's going to print goal. Now let's go ahead and see another example. In this example, I'm going to put it in cell 13. So we're going to go up here and edit this, and we're just going to make it end in cell 1 again. Now, we're going to see in this situation that both paths that it determines are of equal length. So in cases of equal length, it's going to it's just going to go to the path that it first that the program first detects. So in this case, it'll be this path here over this one because they're equal length. So it doesn't matter which path we take. So if we go ahead and run it, we can see that it's going to start the cell here. It's going to move, placing 4, 5, 6, 7, 8 all the way through. And you can see here is where the robot starts at, and you can see the paths. So it decided to pick this first path here. So we're going to go ahead and see it run. So it's going to go forward, forward, right turn, and then a forward motion. Same thing again, goes down here. Going to go here, here, and then all the way to the goal. Again, because both paths are of equal length, it doesn't matter which one we take because both of them are technically the shortest path. So it's going to keep on going, and then once it finally hits this cell, it's going to print goal, and then the program will end. So once again, my name is Zachary Chenoweth, presenting Lab 4, Task 3, Path Planning with No Noise. Thank you for watching, and I hope you have a wonderful day.